So first we learned about an exponent, right? So an exponent is a little number that just hangs out at the top of a number or variable. Right? What does it tell us?
How many times to times the base by?
Exactly. How many times? It's the shortcut way of writing x to the 7, x times x times x times x times x times x times x, right? It's our shortcut way. Just like if we were adding them all up, we would write the number in front. So if all of those were added, we write the number in front of the variable. When they're all multiplied, we write the number to the top as an exponent, okay? So then we moved on. We said, what happens when we have two variables that are multiplied and they have different exponents? And the rule was when the base is the same, can we do this if we have different bases? No, has to be the same base, right? So when our base is the same, we take the exponents and we add them together, right? And we work through, because this is really x times x times x times x times x, correct? So we get to add them. We have x to the 5th, which is different than x cubed plus x squared, right? That looks like negatives there. X cubed plus x squared. Can we combine those?
Yes. No.
No. They're different families when they're being added or subtracted. But when they're multiplied, the reason that this works is because going back to the definition of exponents, an exponent tells us when things are multiplied. So if we're multiplying things that are already multiplied, then we have that commutative or an associative property of multiplication. It just all gets grouped together. So we can't do an addition with different exponents. Okay? Now, then our second step, we said, what if our exponent is raised to an exponent? Right? When they were stair-stepped. What was the rule for that, Tadrian? You multiply them. Right. So when they're next to each other, we add them. When an exponent is raised and they're stair-stepped, we multiply them. So x cubed raised to the 2nd would be what?
Wait.
X cubed.
Oh.
X.
And the whole thing squared.
X to the 6th power.
How are we writing it?
X to the 6th.
Oh,
Okay? And that, because it really means x cubed times x cubed, which gets us back to our step right beforehand that tells us when they're next to each other, we add the exponents together. Okay? So that's our shortcut step. We multiply them. Okay. When we have an entire set, a coefficient, and a variable, all raised, what happens to the exponent on the outside of the set?
It's multiplied.
Yep, and so we distribute it. It works, is it just for the one at the end? Nope, it's for everyone. So if we were to write it out, this really means 2 squared times x cubed squared. So we've now distributed our exponent to both the coefficient and each variable. If I had multiple variables, it would go with each one, correct? So as we work this out, 2 squared is 4. Now we have this rule, it's stair-stepped. So what is my x now?
6.
X to the 6th. Excellent. So these are the steps that we work through. We're going to learn a couple of more. So on your papers, on the 2nd page, we stopped with the distributive property. So now we have the division property. So we're working with exponents. However, we're using some simple addition subtraction properties. So we're going to work through the reasoning behind these initially, and then we'll show the shortcut, just like we did before. We write it all out, we understand why it gets there, and then we get to use the shortcut for it, correct? Okay, so a division property. Let's look at what this really means when we break it all down into the individual parts. So I have x cubed on top, which is x times x times x. I have 3 x's that are multiplied together. I have x squared on the bottom. So how many do I need to put on the bottom?
2.
2. Perfect. Now, way back at the beginning of the year, in our basics, we talk about taking out those ones whenever it comes to simplifying fractions, correct? So what is a 1 in a fraction? Any number over any number, right? Anything divided by itself. As long as you have the same thing on the top and the same thing on the bottom, you get to erase them because they equal 1, right? So if I have 1 winning football team divided by 1 winning football team, they cancel out, I just have 1. Okay? So where are our ones here?
And XX.
And another one. So I have 1 and a 1 there, which leaves me with, do we write the ones? No, because 1 times 1 is 1, and 1 times anything else is itself. So we don't need to write those. So what are we left with? X. Okay, so now let's go back and see if we can come up. Let's do this one, and we're going to work through if you guys can figure out what the formula is for it, okay? So I have x to the 5th, x times x times x times x times x. So I have 5 of them on the top. I have 2 of them on the bottom. Take out our 1s, right? What are we left with? Tadri, what does this come out to? X times x times x.
X to the 3rd.
X to the 3rd.
Cubed.
Yep, x cubed. X to the 3rd. Right, so what do we see as a common rule that's happening? I'm going to write it as a over b. Sorry, that's not what I wanted to do. X to the a power over x to the b power. So I have 1 power on top, right? In this case it was 3. In that case it was 2. It equals x to the a minus b. When they are divided, we take our exponents and we subtract them. 3 minus 2 equals 1. Is that what we had here? Right? 5 minus 2 equals 3. Okay? So when they are divided, you take the top number and you subtract the bottom one. The reason is that we're taking out those ones, right? So I've got a top number of variables, and I'm going to remove all the ones that pair up, correct? So I'm removing everyone that has a pair, and what my answer is whatever I get left, right? And that's simply what subtraction is. In this array, we've got top numbers, bottom numbers, we're removing those pairs. So, if you see it written, they say the formula, that is on, so the property, right there, where it says property, colon, we would write x to an a power, x to a b power. So some variable raised to some exponent, whatever it is. The same variable, right? Because does this work if this is an x and this is a y? No. Same variable raised to a power means that you subtract them. A minus b. So that's your property. So if we have, what if we have multiples? Let's look at this one. the base, we did that base, coefficient base, exponent paper from online. So what is the base for AB to the 5th divided by AB to the 3rd? What's the base that's being raised? AB, the entire thing of AB, correct? Because it's within the parentheses. So I'm going to write my base is AB. Do I need to, could I distribute this out?
You could.
I could, but they're going to be exactly the same, right? Because it's within a parentheses. So I don't have need to do that. So I have AB, and I could write that 5 times. So what does our rule say, though? 5 minus 3. So my answer would be
2 squared. AB squared.
AB, the whole thing squared. Can I write AB squared?
No.
Like this. Does that mean the same thing? No, it does not. Make sure if you're doing an entire base that you've got a parentheses around it. You don't want to lose that. Okay, let's do another example. Okay, let's do that next one in the middle on the bottom. So we have 6x to the 105th over 3x to the 10th. So we want to simplify this. Okay, that's the whole point. This is called simplification for it. We can only deal with things that are in the same family. So in this case, we have different families. We have a coefficient family and we have a variable family. We have to do them separately. Okay. 6, can I do 6 divided by 3? 6 divisible by 3?
It is, yes.
It is. And the answer is?
2.
2. Ta-da! Pink one's done. Should have written that. 2. Now, I have my variable family. Well, I don't know what it is, but I can still simplify it according to my my rule of my top number minus my bottom number. So what are we left with?
95.
105 minus 10.
85. 80.
She said it at first.
You said it at first.
Oh, okay.
The 5 goes down, right? So I'm going 10 less if I was counting back by 10s. 95.
Sorry. You asked me again and
Yeah.
maybe second guess.
As I tell my children, just because I asked you again doesn't mean you were wrong. If I ask you to look at it doesn't mean it was wrong. Okay, so we were able to simplify our coefficients because they were numbers. 6 divided by 3 was 2. We were able to simplify our variables by saying 105 over 10. You could write out x 105 times and then 10 on the bottom and erase those. But what you're doing is you're just taking away the amount on the bottom that matches to the amount on the top and removing those as ones. That's why it's a subtraction. Okay, we're just going to remove the ones that match up. All right. Now, let's do that final example. And it says x cubed y to the 11th over x y to the 6th. Okay? Now, is this the base of xy and we're going to get some exponent up at the top? No, it is not. Because our x and y's have different exponents, there's a way that you could rewrite that, and then these are not grouped together. So we don't have a parentheses. We don't have the same base. So this is not x times y with an exponent. What we are looking at is the same thing that we just did with our coefficients, where we have 2 different problems, 2 different sections. We have our x's that can simplify. We have our y's that can simplify. So first, we will do the x's. According to our rule, the x is what? 3 minus, what is our coefficient that's missing here? 1. Perfect. 3 minus 1. And then I have a y. What would be my workout for y, Tadrian? 11 minus 6. Excellent. So x to the 3 minus 1 is x squared. Y 11 minus 6? 5. Perfect. X squared, y to the 5th. That is a simplification. Again, we're not solving, we're not getting an answer, we're just simplifying. Getting this down. Right. So that is the division property. If it's divided, same base on top and bottom, you subtract the exponents. Okay. Now, what happens, this ties together, the next one that shows is negative. What happens when I have x to the 3 on top and I have x to the 5 on bottom? My rule says that I have to do that my top number is my A and my bottom number is my B. My rule says it has to be A minus B. The order matters. So now it looks like x 3 minus 5, correct? I don't get to just choose which one. It says I have to do the top minus the bottom. Let's look at what that looks like in real life. Why? We have x times x on the top, correct? X cubed. X to the 5th. 1, 2, 3, 4, 5. The goal is to get rid of the ones. 1, do that. What are we now left with on the top?
-2. Oh, 0. None at the top.
Not 0.
1.
1. What are we left with on the bottom?
2.
X squared. Right? Because I have 2 x's on the bottom?
Yes.
So when we look at this, and I have x, 3 minus 5, I get x to the negative 2. Now I have a negative exponent. Right? So that says, when we have a negative exponent, if we're looking at a number line, correct? I've got positive on the right, negative on the left. The amount in between is the same, correct? It just tells you which side you're going on. Okay. The negative here is the same thing. The amount stays the same. It just tells you what side you're on. Okay. When we have x squared, we have that entire number. Say x was 2. Okay, so I have 4, right? I have the whole amount of 4. When it's negative, it has to go on the other side. So what does the other side look like? The denominator. So now, if it was 2, I would have 1/4. So x squared is 4, or 2 squared is 4, 2 to the negative second is 1/4. Same thing, we're working, if you think about it with a number line, got positive one side, negative on the other. Whatever we work across, it's got to be on a different side. In this case, our different side is our fraction line. Okay? So if I have x to the 3rd, what do you think that, to the negative 3rd, what do you think that would look like, Nazarene?
X times x.
To the negative 3rd, where would I put, how would I rewrite that as positive? We don't like working in negatives. It's going to be 1 over
X.
to the 3rd. So I'm just going to move it to the other side, right? Because here it's on top, now it needs to be on bottom.
I understood it, and then we learned this.
Okay, so negative numbers simply mean, remember how we talked about we like to work in addition over subtraction, correct? We prefer, our brains prefer that, we prefer positive. We like to work in multiplication over division, right? Our brains prefer the more positive side of it. In the same way with negatives, we want to change them to a positive number. We don't like leaving things as a negative. we want to change it to a positive. So if I have x to the negative 2, I'm going to move it to the bottom. It means 1 over x to the positive 2. Now I'm happy with that. It's a positive number. We like working with that. Now here's a tricky one. What if they give you that? 1 over x to the negative 2. What's the rule to make your negative positive?
Put it on the bottom.
You have to switch. So if it starts in the bottom as a negative,
It ends in the
you move it to the top. And now it's a positive. Okay? So all we're doing is flip-flopping,
reciprocal in it.
making the reciprocal of it so that it can be the positive number. So if it starts in the top as a negative, we're going to move it to the bottom. If it starts in the bottom as a negative, we move it to the top. So let's look at y cubed over y to the 7th. So step 1 is to do what? We want to get one variable, one exponent. Right now I have 2. So I want to simplify this into one variable. What is my base?
Y.
Y. Perfect. Y is the base. The rule for a division is the top minus the bottom. So I've got y to the 3 minus 7.
-4.
Y equals -4. Excellent. I don't want, rule number 2, we don't want a negative exponent. So where do we move him?
Flip it.
Flip it, put him in the bottom. Y to the 4th. 1 over y to the 4th. Okay. Now, let's look back and see how that works if I were to actually write it out. When it's these small numbers, we can do this. You can check yourself. 6, 7. I don't like doing anything more than 7. But I have y to the 3rd on the top, y to the 7th on the bottom. We're taking out 1s, right? 1, 1, 1. What are we left with on the top?
2 or 1.
1. What are we left with on the bottom? 4. 4.
Or Y.
Y to the 4th. Did we get the same answer?
Yes.
Yes. Our stuff works. Yay! This is the y. Because when you write it all out, that's kind of funny. That's why I use y's. When you write it all out and we remove those 1s, we can see that what we really had was 1 on the top and 4 left on the bottom. Correct? From our y cubed over y7. But when we use our shortcuts, 3 minus 7, -4, I got to put it in the bottom. We get the same answer. You should always get the same answer. Okay, let's work out another one. I'm going to put 2 up here and have you guys come up to the board and do them. We get another good marker. X squared over x to the 7. And we're going to do...
I caught it.
y7 over y
Do
to
you
the
want me
9.
to write it all
Here
out?
you go. Nope, just write do the first step. I want to see this step. Our base with our division rule.
Ooh. Oh wait, so we're gonna do all the steps?
Nope, so from here, yep.
Like,
So you wrote
so I do
y7.
-2 and then I have to flip it again?
Yes, sir. Please always do all the steps.
Wait,
Excellent, okay.
it was
Well, how are you writing it here?
just
What size is it? It's just normal, so that means it's automatically on top. Perfect. Okay, so let's look at Nazarenes here. X squared over x to the 7. This really means x 2 minus 5. All right, top minus the bottom. So she got, sorry, what should it be? It's 7.
Oh, sorry.
Copy error, that's fine. I knew you were thinking 5. 2 minus 7 is
5.
Negative 5. X to the negative 5 is automatically sitting in the top. So to make it positive, we stick it in the bottom. 1 over x to the 5th. Perfect. All right, this next one, x to the 7, or y to the 7 over y to the 9 means y to the 7 minus 9. Y to the negative 2, that's sitting in the top, so we're going to move it to the bottom. 1 over y squared. Excellent. So now, 1 over x cubed. X to the negative 3. What does that look like instead? Do we want to leave it like this?
No.
No. So what are we going to write instead?
X cubed over 1.
X cubed over 1. Do we need to write the over 1?
No.
Nope. X cubed. Perfect. Let's work out our couple of equations. Negative 2x to the negative 5th over 4. Okay. So we have 2 different sections, correct? I have we've got our consonants here at the front, and then we've got our variable. Can we work out negative 2 over 4x to the 5th? Do we want to leave it like this in the first place? No, let's rewrite it a little bit better. So negative 2 over 4, and what are we going to do with that x to the 5th? Do we want to leave
Move it.
x to the negative 5th in the top there? What do we want to do? We're going to move it to the bottom and make it x to the 5th. So now I've rewritten with 1 less negative. And we don't ever want to have it as a negative exponent. So we're going to rewrite it so we have positive exponents. Now I'm going to simplify. Can I do anything with the x's? Do I have any x's on the top or the bottom? No. So that part of the equation I know is going to stay the same. The x is going to stay in the bottom as x to the 5th. And now I have negative 2 on the top and 4 on the bottom. Remember, 4 is really 2 times 2. Take out my 1. So what am I left with at the top? Negative 1
And 2 at the bottom.
over 2 of x to the 5th. That would be your answer. Now when you guys got those. All right, let's work through a harder one. Next step. We'll keep stepping up. Okay. X to the 4th, y to the 5th. So now I'm dealing with 2 different bases. X to the 6th, y to the negative 2nd.
Oh, wow.
Okay. So step 1, before we do anything, we want to rewrite this expression with no negative exponents. So we're going to, x to the 4th is fine. Y to the 5th is fine. Okay. X to the 6th on the bottom is fine. Y to the negative 2 on the bottom is not fine. Where are we going to move it? It's on the bottom. So we're going to move it to the top. Y squared. Okay. So now I'm rewritten with no negatives. Now we can start working through our steps. First, we're going to go back to the very beginning. Okay, we have 2 bases that are the same that are multiplied. What was the rule for this? The bases are the same.
You multiply them. Add them.
We add them. So now I have x to the 4th, y to the 7th over x to the 6th. Right? So we took, can we do anything else with y's? No. Nope. So they're just gonna hang out. He's gonna hang out for a while. Now, I'm gonna deal with my x's. My x's are a division rule. The division rule says I take the top minus the bottom. So I have x to the 4 minus 6, y to the 7th. Right? So now I have x to the negative 2 times y to the 7th. Y to the 7th is just fine. X to the negative 2 is a problem. He's currently attached on top. How do we get rid of it? Move him to the bottom. X squared. So our simplified answer is y to the 7th over x squared. If we were to write it out, we'll deal with all the y's because we need to move them up. I had 6 x's down here. We've taken out 4 x's on the top, 4 on the bottom. I was left with 2 on the bottom. We got our 2 on the bottom, right? Perfect. Now, if we add coefficients to that, does that change anything that's happening with our variables?
No, ma'am.
No. We just have to, there are different steps. So 14x4 y cubed over 21x12 y4 z5. Okay? Step 1, work through steps. Work through them one at a time. This is 3 separate problems, right? Problem number 1 is coefficients. Problem number 2 are your x's. Problem number 3 is your y's. Okay, so we're going to work through each one individually. Problem number 1, 14 over 21. How do we simplify that? We break it down into factors, correct?
Oh, right.
So I've got 14.
2 and 7. Oh, sorry.
Yep, 2 and 7.
And 3 and 7.
3 and 7. What's my 1 I can take out?
7.
7 and 7. So I'm left with
2/3.
okay,
Or 2.
2 on top, 3 on the bottom. And feel free to just do a long fraction line if you need to when you're working through, okay? So, problem 1 done. Problem 2, x's. X to the 4th over x to the 12th tells me that I have x to the 4 minus 12, correct? Okay, so we have a step 3 for that one. Now we're going to go on to our y's.
X minus 3. X 3 minus 4.
3 minus 4.
I mean y 3 minus 4.
Y 3 minus 4, perfect. Okay. And my z to the 5th is perfectly fine. I don't have anything else, so I'm just going to leave him in the bottom. Z to the 5th. Okay. So now we've worked through. Oh, sorry. There's 4 problems, not 3 problems. We've worked through all 4. We've worked through our coefficients, through our x's, through our y's, and our z's. Now we simplify what we have. So 2/3. So I have my long fraction line. 2/3 stays the same. X 4 minus 12 really is negative 8. Okay, can I leave negative 8 on the top?
No, but we'll change.
So I'm going to put him on the bottom. Okay. Y 3 minus 4 is y to the negative 1. Can I leave him up here on the top? No, I'm going to move him to the bottom. Do I have to write the 1?
No.
No. Okay. Z to the 5th is already on the bottom. Okay. Can I simplify it anymore?
No.
No. I've combined all my x's, I've combined all my y's, combined all my z's. None of them have negative exponents, so my answer is 2 over 3 x to the 8th, y, z to the 5th. Okay, see how we took it? We broke it down into individual steps, worked each individual problem, and wrote it appropriately. So those are the things to think through of, is it written appropriately? Do I have negative exponents? I can't write it with negative exponents. I need to change it. Which groups go together? I highly recommend colored pencils, underlining things or circling the ones that match in different colored pencils. Okay, so now that we've learned the negative property, there is a zero property. Now back when you're doing multiplication and you have x times 0, it's 0, right? Anything times 0 is 0. If you have an exponent, x raised to the 0, okay, that's 1. The answer is 1. So same thing, x to the 1 is the actual base, correct?
Because of the x, that's why?
No, it doesn't matter. Any variable.
Well, no, that's what I'm saying. I mean, x raised to 0 equals 1 because of the x. Because x is 1.
Anything raised to the 0.
Because of
I
the
could
0.
say 49 raised to the 0
That still equals 1?
is 1. Means I have none of them.
I see. Okay, that makes sense.
Okay, but it doesn't make the rest of my problem go away. Okay, so when we are multiplying something times 0, it's saying everything that I have in my room times 0, you have nothing. So I don't even have a room, right? So if I was using your cute little bag, if I multiply this times 0, it means I don't even have that.
Right.
It goes away. Now, if I say I have no more groups of it, I still just have this.
The 1.
Okay, so you have the 1. So, because this is telling you how many groups of it you have. So we still have 1. The thing that comes into play is when you have, this is why it works. Say I have 2 times x to the 0. If x was 0, my whole answer would be 0, because I've got 2 times 0 equals 0, right? But what this is really saying is, I don't have any of these x's.
So it's just writing it for no reason.
Which is 1, but I still have the 2.
Right.
So I still need the 2.
That's confusing.
There. Because 2 times 1 is 2, right? Anything times 1 is itself. Okay. All that long confusing around to say this is something you just need to flat memorize. Okay. So x raised to the 0 power will always be the number 1. Just replace it as a number 1. Okay? So, if we have, and let's look at it this way, 3 or x cubed times x to the 0. Let's look at our initial way back in the wind. I've got 2 things that are multiplied. What does it say? When the bases are the same, what do we do to the exponents? We add them. Perfect. If you need to write your little box, always write your box. So now I have x, 3 plus 0 is 3, right? So what could I really do this? X times what? X cubed times what gives me x cubed? 1. Okay, so my x to the 0 is really a 1. X cubed times 1 equals x cubed because we replaced x to the 0 with 1. That's also why it works whenever we work out our 3 plus 0. Okay, now, so if I had it in a division, x cubed over x to the 0, it tells me This really means 3 minus 0, correct? Not 6. Whatever's on top minus the one on the bottom. 3 minus 0 is 3. Still left with the original because that was really a 1. Making sense?
It makes sense. It's just...
Okay. So the x to the 0 working as a 1 makes sense when we go back to our original shortcut steps, right? Top minus the bottom, or if they're multiplied, we add the exponents together. We end up with just that original one. So it's just like it disappears. Okay, so that's our justification for it. Okay, also, if we have y to the 5th over y to the 5th, what rule are we working in? Our division rule, correct? This says I have y to the 5 minus 5, which gives me y to the 0. Is my answer 0?
No.
The answer is 1. Okay? Where's our justification? Y, 2, 3, 4, 5. 1, 2, 3, 4, 5. Y to the 5th divided by y to the 5th. We take out the 1s. What are we left with? 1. It's not 0 because we have this imaginary 1 coefficient there. So we get 1. They're the same. Okay? I've matched up everything on top with everything on bottom. All I have left is 1. 1 whole 1. Okay? So let's do one negative 1 that, I like their observing a pattern one, so we're going to go through that one with practical numbers. Okay. Okay, 3 cubed. 3 times 3 times 3.
9.
9 times 3 is 27. Okay? 3 squared, 9. 3 to the 1, 3. 3 to the 0, 1. 3 to the negative 1, 1 over 3. All right, so see our pattern goes, we work down. So we start at the highest. As our exponents get smaller, we're working towards the origin, and then we're flipping and going on through our fractions, okay? Now, let's do this one. Y to the negative 5th, z to the 5th, over y to the 5th. And it's all raised to the negative 1. Step 1 with PEMDAS, right, says we work from the very outside in. So before we start simplifying anything with our rules, we need to make sure that everything is written correctly. What is our first rule with exponents? You cannot have a negative exponent written. So, what is the very outside negative exponent?
1.
Negative 1. The whole thing is raised to the negative 1. So what should I do with my fraction on the inside?
Make it positive.
We need to change this to the negative 1. So I can either do one over this entire fraction, right? Now I have the problem. I have division and a division in the bottom. Remember back we said that's a no-no. You can't divide. What do we do instead?
Multiply.
Flip and multiply. So now I have y to the 5th, y to the negative 5th, z to the 5th. Right? So So I took my -1 on the outside and I flipped this entire fraction over so that it's positive. It also works because remember an exponent means it's been distributed among, so it has to be distributed to each factor, correct? So that would make everything negative, which means it needs to change sides. You know, it's like Red Rover. Did you ever play Red Rover? Red Rover? Let Miss Jamie come over. And it, when you have two different, or any kid games, or checkers, when you're trying to get from one side to the other. Okay, so if it's negative, you want to jump to the other side. Okay, so you're always just jumping sides on it. When our -1 on the outside distributes to each one, it's like, oh, as soon as that negative hits, it's got to jump to the other side to make it positive. So instead of individually jumping them all, we just flip the whole fraction at once. Okay? So we put everybody on the other side. The fifth now needs to go to the top. The things on the top go to the bottom. Makes our fraction positive. Now, we look at it again. Is there something else that's a problem? Step 2. So this was step 1. Step 2. Can we start solving this yet? What's the problem? There's a -5 as an exponent. So what do I need to do with it? How do I get rid of it? I got to jump sides. So now I have y to the 5th, y to the 5th over z to the 5th. Okay. Now is it written properly? Tadrian's nodding yes.
No.
Yeah, Tadrian's nodding yes. There's no negatives.
Can't you combine the y's?
So now we get to start using our rules. Now that it's actually written properly, we have no negatives in there. Now we get to use our rules. I've got same base, which tells me I do what to the top? Add them. Perfect. So I have y to the 10th over z to the 5th. Okay? So we took this ugly, nasty equation or expression here, and we simplified it to y to the 10th over z to the 5th. Okay? So now, in real life, or in a science lab, or whatever you're doing, there's something that we work with a lot that has lots of different exponents on it. And that's called scientific notation. So I'm going to do a real life, or real what they say life, right? Scientific notation. So if I have something and we're talking about the speed of light or how much money Bill Gates has, there's lots of zeros in those. Do we want to use all those zeros? No. No, we don't want to use all those zeros. So we rewrite them. So say I have $590 billion for SpaceX to send me as the next astronaut on that journey, right? That was pretty cool. They just launched those 4 civilians. So I've got this. Do we really want to write it like that? No. We're going to write scientific notation. Remember, that's one number and then a decimal and the rest of your numbers and then the zeros. Okay, so I've got 5.9. Those are my only numbers that are not zeros. And then how many times, if I have the decimal between my 5 and my 9, how many times, let me remind you guys, on scientific notation, your first number has to be a number between 1 and 9. Okay? We can't have 59 point something. You also can't have 0.5. Okay, number between 1 and 9. So I've got 5.9. How many times would I move this? 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the 8th power.
Why is it 10?
Well, it's always multiplied times 10 because 10 gives us the zeros. So instead of writing 590 billion, I have 5.9 times 10 to the 8th. Okay? Which is very different Then 5.9 times 10 to the negative 8. Because the negative 8 says I have to move my decimal to the negative, towards the negative line, right? And if I have a number line, I have positives and negatives, so I've got to go 1, 2, 3, 4, 5, 6, 7, 8. I fill in all the gaps with zeros, and I have no money. Now, okay? However, if I'm talking about the size of an atom, I might have something to the negative 8, right? So our exponents are very important with scientific notation. The problem, where it gets difficult, is when I'm dealing with a lot of these numbers, trying to figure them out. Well, we know our exponent rules. We can just simplify. Okay, so we've got the same things. So if I have .4 times 10 to the 18th, okay, times 2.4 times 10 to the negative 7th, okay. This is really, remember they're all multiplied, so I'm going to take out those x's so we don't get them confused with a variable. 3.4 times 10 to the 18th times 2.4 times 10 to the negative 7th. Remember, we have those commutative rules. If it's all multiplied, we can arrange it in whatever order we want. So that would be 3.4. I like putting my numbers together. Times 2.4 times 10 to the 18th times 10 to the negative 7th. There's a couple of things that I see I can do. I can multiply 3.4 times 2.4. Okay? That's 8.16. Right? I can also look and see I have two bases that are exactly the same. So what's our rule when we have two bases that are the same that are multiplied? We add the top. So I have 10 to the 18 plus negative 7, which is the same as 18 minus 7. So I have 8.16 times 10 to 18 minus 7 is 11, right? So I could write that scientific notation, 8.16 times 10 to the 11th. So we've taken what seems to be an extremely difficult problem and said, what are our basic math rules? We're just going back to the very basic. Everything is, when it looks real big, it's built with the same bricks, okay? So the Eiffel Tower and, it's built with the same individual bricks I could build my house. It's a lot bigger, same bricks. Need the same foundation, the same steps, okay? So we have our regular multiplying our numbers. We used our rule for exponents. We didn't have to multiply anything out into big numbers, right? We didn't get a zillion zeros. We have 8.16 times 10 to the 11th. In the same way, what if they were divided? What if I have 1.5 times 10 to the 12th over, we're going to work this one as a couple different steps, 10 to the 13th, 2 times 10 to the negative 9th. Step 1. Is this written appropriately? No. No. Why not?
Because they're over each other.
No, it can be over.
Sorry.
I've got a negative exponent. I'm going to rewrite it. 1.5 times 10 to the 12th. How do I get rid of this negative exponent, Tadrian?
Put it on top.
Excellent. We jump sides. Put him on top. Now he's just 10 to the 9th. 2.5 times 10 to the 13th. Right? we can work this through, right? We can multiply our numbers. 1.5 times 2 is 3. 15 times 2 is 30. So that's why, and I have one decimal place, so I've got a 3 times 10. What is my rule? They're multiplied, so what do I do with my exponents?
Plus.
Add them together. 10 to the 21 over 2.5 times 10 to the 13. Okay, so now we work it the same. We have our 3.5 divided by 2.5. No clue. What did they say? Actually, they worked it a little different. Pause. I don't know that I copied it down right. Okay, they want you to simplify it first. Okay, let's go back. They want us to go through the simplification first. In this case, when we have the negative 9 on the bottom, we have these multiplied here. You can go ahead and move it, okay, but in this case, we're going to go ahead and work through our unit all on the bottom at the same time. So we're going to leave our top 1.5 times 10 to the 12th. And on the bottom, what do? We multiply our numbers, just because it gives us 5. So 2.5 times 2 is 5, right? 25 times 2 is 50. Have one decimal place. What is our rule when we have the basis? So what does this look like? 13 minus 9, right?
13 minus 9 is 4.
Is 4. Okay. So now we automatically got rid of our negative by going ahead and combining those.
Okay.
All right. So now I've got 1.5, or 15 divided by 5 is 3. But I have a decimal place, so it's 0.3. Okay, and then what is my rule for dividing?
Multiply.
When they're divided, what do we do with our
Do we not multiply?
12 minus 4?
Oh.
Right? We subtract them. So we have 0.3 times 10 to the 8th. All right? Does that make sense? Perfect. Let's look. If we are going to rewrite, where am I at? Just a couple minutes. Let's work through a couple of examples because you have lessons this week and then a test.
You have a test this week?
And due for next week.
You have a test this week? Tuesday?
Yeah, so finish this one and then do the test, yes. Okay, so we're gonna go through a couple of examples, Adrian, just so that we can get it with the test. Did you get the scientific notation? Do I need to do one more?
No, I got it.
Okay, so if we were going to write, if they asked you to write .000000024 in scientific notation, how would we write that with an exponent? Here's our numbers, right? Our decimal needs to go between the 2 and the 4, so we need to have 2.4. How do I get from my decimal here to down there? 1, 2, 3, 4, 5, 6, 7, 8. I had to go backwards 8 times. So I have 2.4 times 10 to the negative 8. If they ask you to write in scientific notation, this is what it would look like. Here's the number one error that gets the most confusing that I've always seen for scientific notation is to say, I know my decimal needs to be over here, so I am moving my decimal this way. I'm moving it to the right to take it down there, so it must be positive. So that should be 10 to the 8th. Okay. Remember that you are starting in your scientific notation, and it is telling you where to go. So you're actually working backwards, right? So you have to think of, where would my scientific notation tell me to move? My scientific notation tells me which direction to move my decimal. So although in the original problem I'm moving to the right, my scientific notation tells me I have to move to the left. So therefore, it's a negative in the scientific notation. Does that make sense? So when you're starting with the original number, to think about where you're going, which is why I always like to just box my numbers. Because say I have this, I know my first number has to be between 1 and 9, so my decimal still has to be right there, 2.478. So I like to box that and say, how do I get back to here? How do I get back to it? Because that's what scientific notation is telling you, is how to get back to your original really awful number that you don't want to write all the numbers for. Okay. So this whole chapter, we're going to do a quick review over the different types, is about simplifying with exponents. Okay. The simplification with exponents means that as we step into the next section of breaking down bigger polynomials and reducing, we have some rules that makes it easier faster, right? So that's the point of it. Okay, so if I have 2.9 times 10 to the 18th times 4.5 times 10 to the 10th, step 1, what would we do? Which part's step 1?
Simplify.
Okay, yeah, we want to simplify. So this really tells me that every single one of these numbers is all multiplied together, correct? So I'm going to find my real numbers and multiply them. So I would do 2.9 times 4.5. And then I would multiply my tens together. What is the rule that we have for exponents? If your bases are the same, we add. Okay? So we would have our number answer times 10 to the 28th. Oops, not x, 10 to the 28th. Let's look at x to the negative 2 over x to the negative 4. How would you rewrite that? What's the problem? The negative exponents are the problem, correct? So I'm going to rewrite this as what?
X, flip it.
Flip it. X to the 4th, perfect, over x
Squared.
squared. Okay. Now I want to reduce it. Is that as simplified as it can be?
No.
No. My rule says that when I have the same bases divided, it's the top one minus the bottom one. So my answer is
2.
x squared.
Oh yeah, sorry.
Okay? Because if I wrote that out, I would mark out 2 of them and I'm left with 2 on the top. Got it? Let's look at one more. It says tell, this one uses all of the the steps that we've been learning. We're going to combine them all together. Okay? So I have x squared plus 3 over 4x cubed plus 3 over 2x. We want to know if that equals 7x squared plus 3 over 4x cubed is what they're asking. Okay, so this is where we're working. Okay, step 1, what do they want us to do? Add what? 2 fractions. The rule for fractions is the denominator has to be the same. Are the denominators the same? No. So we have to make the denominator the same. What is our least common denominator? 4x cubed is going to be the, right? Because this can't get any smaller.
Okay.
Right? So over here, what am I missing? 4 is really 2 times 2. And I have x cubed, right? So I have 1, 2. I'm missing the second 2. I'm also missing 2 x's, right?
Right.
So if I do 2x times 2x squared, do I get 4x cubed?
Yes.
Yes. But if I do this on the bottom, remember I can only multiply times a 1. I have to do it on the top. So I'm now going to rewrite 6x squared over 4x cubed. Okay? Now, what are they asking me to do? Add 2 fractions. Are my bases the same? My denominators? Yes. Now I can add them. My denominator stays the same and the top just combines together. Okay? Now, can I add 1 plus 3 plus 6? No. They're different families because they're being added. They have to be the same family. So we have 2 different groups of families. We have just number families, and we have x squared families. Okay, so I can add the x squared families. So I have 1 plus 6,
7.
and I have to tell what family it is. Do I do anything with my number family?
Can you add it to?
It can't be added. It's not a part of the x. These are Thomas's and those are Davis's. They cannot get in the same band. Okay? Plus 3. And my denominator stays the same. Did we get the same answer?
No. Oh, yes.
Yeah. So we would say yes. All of this can reduce down to that. Those would be the same. Okay? So this took several of the things that we have to remember from the past, right? If this was multiplied, if we ended up where we had multiplication, then we would reduce that. Now, would it be tempting to say, oh, well, they told me all this new rules about reducing, and I've got an x squared on the top and an x cubed on the bottom, and I can subtract those. Can we do that? No, because there's an addition sign in the middle. So this is grouped as one thing. We cannot separate it out. If we did rewrite it, like that, because that means the same thing, right? We can take and separate it, rewrite it with the same base. Now I can reduce this, right? 7 over 4x plus 3 over 4x cubed. So I can rewrite it as 2 different fractions. I can reduce x2 minus 3 is -1, so I have to leave it in the bottom. But I can't write it as one single fraction to reduce it. You'd have to separate it out into the individual fractions to reduce it. Right? Got it? Okay, so you guys have through lesson 29, 26, 7, 8, 9. And then your chapter 3 test is listed on there. I'm deciding whether or not to have that. due on Tuesday. I'll let you guys know in the email. Because we may just do a quick review. I need to look ahead and see how far we're behind we are. All right? Got it? Have a good trip.
Thank you.
You're going to Louisiana?
Texas.
Oh, just Texas.
Yes.
Okay. Well, you going to say?
No.
Okay. Well, have a good day.